Okay, hello again. Today's video we'll talk about equations of lines and planes, which are going to be slightly different than what you're used to in just two dimensions. For lines, it's going to be fairly different. Planes you haven't really dealt with except you were just in the XY plane. But when you're in three dimensions, it can get a lot more difficult. So, let's go ahead and take a look at how to write a line. So, we're essentially going to be using this diagram here to write our line. So our line is this red line going through here. We don't know too much about it, but we need two things in order to write this line. We need a point that's on the line. So that's going to be this point up here. Another thing we need is the direction of it, which, if you know the direction, that's the same thing as a parallel vector. So what we're going to end up doing is use the parallel vector or just 2 points on it, whatever you want to use. We need to change our point into a vector. And all you have to do is change the types of brackets and that's done. So you don't really have to worry about that point too much. From there, we use vector addition, which is something we talked about last video. So if you look at this diagram, to get to any point on the line, we'd be taking our vector P0 and adding some multiple of this parallel vector. So that ends up giving us the equation of any vector, essentially, is our point on the line plus some arbitrary t value or a value times our parallel vector. And this is going to give us a vector equation for any point on our line. Hopefully that makes sense. Now, if you wanted to write this out parametrically, this is essentially what it would look like. You have an equation for x, you have an equation for y, you have an equation for z. And the a, b, and c values, those are associated with your parallel vector. So that's how you write a line in 3D. We'll talk about some more properties in class, but don't get too caught up on it. I just want to make sure you know the basics of it. Now, a plane. First of all, what is a plane? Well, a plane is any two-dimensional surface in multiple dimensions. The best way to think about it is we live in 3 dimensions, piece of paper, that is a plane. Wherever you have it set up, that's going to form a plane in 3 dimensions. So these happen a lot. If you do any engineering, there's planes all over the place that you have to worry about, because you have to worry about sides of a house, the top of the house, floor, everything. So you need to have a proper equation to be able to get everything set up into a proper direction. Now, for this, we also, again, need a few things to work on. And it's still just the 2 things, but they have changed. Because you need a point in your plane. And this could be a vector that leads up to a point in the plane, that's fine. The other thing you need is a normal vector. Quick question, what is a normal vector? Well, that is a vector that is perpendicular to the plane itself. So if you draw any vectors in your plane, a normal vector, well, when you do the dot product of them, it's going to come out to 0. And that was true for all normal vectors and all vectors in the plane. So you need to have that. Conversely, you could have 2 vectors that you know in your plane. Well, if you do the cross product of them, you know that gives you a normal vector, and you'd use that. Now, how does the normal vector help? Well, we're going to essentially be using the dot product again. So the way we get the equation, well, if we go between any 2 points in our plane, well, there's this vector and this vector. And going across from them, that's vector subtraction. So we'll want to use vector subtraction. And we know that this vector is in our plane, and we have a normal vector to it. So if we take the dot product of the 2, it's going to be 0. So we end up with this equation where r is any vector that leads to a point in the plane. So that's the basics of how to find the equations for a line or a plane in 3 dimensions. So if you have any questions, feel free to ask. Otherwise, see you in class.